Okay, I think yeah, while we waiting for the rest of the people to join us, okay, I think we should I'll do some I'll kickstart first, okay. I'll give some introduction, and yeah, then I think the rest of participants can join subsequently, okay. So hi everyone, my name is Kwan, okay. I am the product manager taking care of TE sensor in Excelpoint, and today I'm also the moderator for this webinar. And again, thanks for joining this webinar. So in this webinar, you will learn how sensor and the HVACR systems are evolving to meet the industry needs for much finer control and improve efficiency and performance. So when we talk about HVACR, we're actually pointing to heating, ventilation, air conditioning, and refrigeration. So we'll be sharing with you the sensor devices that are more rugged, better accuracies, wider operating range with enhanced performance that are transforming the HVACR industry today. Our main speakers today, Paul is a TE account manager, and Devin is the TE product knowledge and training manager. Both of them are based in US. And due to the time zone differences, they have pre-recorded their presentation, which we'll be sharing with you later. So after the sharing of their presentation, we'll go into a few more success story sharing with you by Vincent, and we'll go into the Q&A section where you can actually ask questions live, and then we will be answering to your question. So along the webinars, if you have questions, you're always welcome to type in your Q&A. Type your question down so that we can look at your question and then we can attend to it later. So also joining with us today in this webinar, we have the TE sensor team taking care of the ASEAN and ANZ region. So I would like to go around the table, giving them a chance to introduce themselves, starting with Boon Heng.
Hi, everybody. I'm Heng here. I'm the TE of Southeast Asia and New Zealand. I hope this webinar will be benefit for all of you all for future knowledge. And of course, please raise your question if you have any concern regarding about the sensors. And of course, we hope to equip well for your knowledge sensors that we are offering nowadays, such as for IoT, industrial monitoring, and most of our sensors is more. And I'll give back the time to Kwan. Okay, thank you very much. Yeah.
Okay, thanks, Heng. Now let's Vincent have a chance to also introduce himself.
Thanks, Kwan. Hello, everyone. I'm Vincent Yang, and I'm the field application engineer. So I'm supporting the South Asia for the product technology and the application details. Later, I will also share some of the additional to the presentation. I will also share some of the win case and the successful story on the HVAC application. So, during the presentation, if you have any questions, just as Kwan mentioned, you can just text on the Q&A section on the bottom, and or we can go to the Q&A section. You can just ask directly. Okay, so hopefully you enjoy the webinar. Thank you.
Thank you, Vincent. Thank you, Vincent. Yeah. So yeah. Next is Chin Len.
Yeah. Hello, everyone.
Let's introduce yourself.
Yeah. Okay. Thanks, Kwan. So hello, everyone. Welcome to today's webinar. So this is Chin Len. So I'm the FAE taking care of the TE products for Excelpoint Singapore. So if you have any questions, so feel free to let us know so that we can answer your question accordingly at the end of the webinar. Thank you.
Okay, thanks, Chin Len. Next up is Chang Rong. Chang Rong, cannot see your face. Hi, Chang Rong.
Hi. Hi, good morning, everyone. This is Rong, and how can I say? Today is the first time that Excelpoint give a webinar to our Singapore and our APAC audience. Yeah, wish everyone have enjoying the webinar and have a good time with the team.
Thanks, Chang Rong. So I think lastly we got Ming on the line as well. So Ming, let's tell the people which region you're taking care of.
Okay. Hi everyone. So first of all, I would like to say thank you for joining the webinar today, hosted by our partner Excelpoint. So my name is Min, technical sales from TE Sensors. So I'm based in Ho Chi Minh City, Vietnam, and I'm currently supporting for all the TE Sensor customer in Vietnam market. So I hope that after the webinar today, we can get a better understanding about TE product, what we can offer. And if you have any questions or any support needed, my team and I, along with Excelpoint team, we're gladly to assist you. So have a nice day, and I hope you enjoy the session today. Thank you.
Okay, thanks, Ming. And I think that's all our panelists today. Okay, without further ado, I will kickstart the presentation now.
In today's webinar, we're going to be covering a variety of topics concerning sensors in HVAC and refrigeration systems. And we'll dig a little deeper into the following areas: the evolution of sensor technologies in HVACR, how sensor technologies and controls have evolved over the years, trends in HVACR, where is the market heading and what is driving it, sensor technologies in HVACR, what are the main sensor technologies used in HVAC and where are they used. Next, some of the applications supported by sensors. Then we'll look at some sensor technology comparisons. Each sensor type can use a variety of technologies, and each of those have advantages and disadvantages from a performance and cost standpoint. And then when we look at some specific use cases for sensors and where they are most popular. Then finally, we will answer your questions concerning any of the topics we covered or any other general questions on HVACR and sensors. Sensors, as well as controls, have evolved over the years and will continue to evolve to meet the needs of OEMs and people throughout the world. At the start, controls were very simple on-off controls, and sensors were typically electromechanical switches or very inaccurate analog sensors that fed simple threshold controls. As electronics became more sophisticated, HVACR systems were developed with more accurate and reliable analog sensors, primarily temperature and pressure sensors that were used for control and feedback. The last 30 years have seen a push for HVACR systems with higher efficiencies, finer temperature control, as well as the desire to monitor and regulate other physical parameters like humidity, air quality, and more. That drove the need for more sensors to monitor and control the system, but also new types of sensors for occupancy, humidity, CO2, and others. Future systems will need to be more efficient and provide better comfort, but also may include a wide range of built-in diagnostic functions to ensure reliable and efficient operation. We will look at sensor trends next, but they include developments to make them smaller, faster, and smarter. Sensors are evolving in several ways to better meet the needs of customers for cost-effective and accurate measurement of a range of physical parameters. The HVACR industry is driving change in sensor technology and development in a number of areas, including the following. First, harsh environments. HVAC and refrigeration applications often involve harsh environments that can include high vibration, fast temperature cycling, high humidity or condensation, high EMI or EMF, rapid pressure changes, and more. OEMs require sensors that can perform reliably and provide accurate data over the life of the equipment. The cost to replace sensors or other electronics can be very expensive, especially for large equipment, and the cost for downtime, especially for commercial applications, can be extremely high. So rugged and reliable sensors are becoming more important. Next is digitization. As discussed before, early sensors were just electromechanical switches, which evolved into more accurate analog sensors. Today's sensors that incorporate digital communication protocols like I2C and SPI allow for easier integration into today's sophisticated electronic control systems. Digital sensors also eliminate the need for additional circuitry like amplifiers and ADD converters that add cost and introduce additional errors into the process. Next is sensor fusion, which is the ability to combine multiple sensor data and allows for finer system control, better accuracy, and lower cost. Examples include humidity and temperature sensors that allow for monitoring and control of both parameters for better personal comfort or equipment control, but also allows for the calculation of the dew point, which can be an important parameter. Another example is a pressure temperature sensor that can provide a more accurate determination of the status of the air conditioning cycle in many instances. Next is lower power. Most electronic systems, including HVACR controls, are becoming more efficient, and the less power the system uses overall goes into the efficiency rating, which can be an important selling point for many OEMs. Digital sensors especially can be designed to operate in a sleep mode, which draws very little power and can then wake up as needed to provide the data to the system. Next are wireless sensors. While most HVAC systems today utilize wired sensors, there is a move to wireless sensors in certain applications where long wire runs can be very expensive, or there is a need for a remote sensor. A variety of communication protocols can be used, including Bluetooth, Wi-Fi, Zigbee, and others. All the instances of hacking and unauthorized access to systems are pushing all wireless products to be more safe and secure. And then finally, miniaturization. As more features are added to systems and systems are required to be more efficient, this drives all electronics as well as sensors to be smaller and to pack more features into a smaller area. Many of the areas discussed above fit with miniaturization, including sensor fusion, digitization, and lower power. Similarly, there are several trends driving the HVACR industry. Some are related to the trends for sensors, and most are similar to trends in other industries. The U.S. Small Business Administration notes that HVAC equipment accounts for 40% of all energy usage in commercial buildings. Many of the trends in the industry revolve around reducing energy usage and minimizing or eliminating the use of fossil fuels and ozone-depleting refrigerants. Because of the overall amount of energy used for HVAC, as well as the high cost of energy in certain areas, energy efficiency has been and continues to be important in HVACR systems. Systems are generally provided with a seasonal energy efficiency rating, or SEER, which is the ratio of the cooling output of an air conditioner over a typical cooling season, divided by the energy it uses in watt hours. Energy efficiency can be improved by better system control and more efficient components, such as motors, fans, and compressors. Sensors play a key role in not only improving the initial efficiency for systems, but also providing the diagnostic capability to monitor systems in real time for efficiency and to help determine the cause or causes for any changes to the system. Like other industries, HVAC and refrigeration continues to push for green technologies. The periodical Green Buildings points out that green HVAC systems consist of smaller, less costly, and less complicated heating and cooling equipment. It also notes the system focuses on using energy-efficient designs that can collectively reduce the size of the heating and cooling system by 30 to 50%. Green also means looking at the refrigerants used in cooling systems and moving away from ozone-depleting refrigerants, which require several changes to how the system operates and is monitored and controlled. Lower global warming refrigerants typically have a higher flammability rating than those that are currently being used, which will require new sensors and controls and other changes to the system. On the heating side, there is a push to move away from fossil fuels and to solar or geothermal systems. Those systems typically require different control methodologies and consequently sensors with different sensing capabilities and requirements. Commercial HVAC control systems ensure tenants are comfortable, energy usage is efficient, and operations are running smoothly. Most HVAC control systems have user-friendly interfaces that building owners and employees can easily operate to control temperature settings. With more control over the building's HVAC systems, commercial building managers continuously monitor and quickly respond to abnormalities in the building. HVAC control systems can help building owners manage their energy consumption and costs. The control system can be used to turn off lights when the building's empty, adjust temperatures based on current occupancy or the weather outside, or manage air quality and CO2 levels. Sensors play a key role as they are the eyes and ears of the control system and allow it to understand the current state of the building's environment, that is temperature, humidity, air quality, etc., as well as the operating state and efficiency of the heating or cooling equipment, as well as occupancy, lighting, and other parameters. IoT, or the Internet of Things, is rapidly changing the consumer landscape, but also many industries, including HVACR. IoT helps the HVACR sector transform from a centralized system to a distributed, smart, and integrated system, which enables fast computations and efficient decision-making. Today, lower technology costs and the increasing availability of digital and wireless technologies are making it easier than ever to inexpensively gather sensor readings for various HVAC components. On top of that, recent advancements in data storage and cloud computing allow building operators to access the multitude of HVAC data points such as temperature, pressure, flow rate, and gas concentration. Cloud computing or big data allows for much better data analysis, which allows for higher efficiencies, better fault detection and analysis, and better overall equipment utilization. Smart building HVAC controls help to optimize the amount of conditioned, that is heated or cooled air, supplied throughout a building. Smart controls optimize airflow using data provided by CO2 levels, occupancy, temperature, humidity, duct static pressure, and air quality sensors, and modulates the amount of airflow in one area without starving or over-ventilating another. HVAC systems face leaks, blockages, and deterioration on a regular basis, which leads to a natural degradation of the system over time. To detect and prioritize faults early on, IoT-powered HVAC systems come equipped with automated fault detection and diagnostics functionality that includes a combination of sensors and algorithms. All these trends help contribute to reducing operating costs and ensuring systems operate reliably and efficiently and help extend the life of the system. Operating costs include not only the initial cost of the system, but ongoing costs for energy, maintenance, and upkeep. Now I'll hand it over to you, Paul, to discuss sensors and IoT, and then look at some specific sensor technologies and applications.
Thanks, Devin. As many of you know, the Internet of Things is significantly influencing the HVAC industry. We at TE spent a lot of time thinking about the future, and the evolving IoT is certainly one of the areas we're giving a lot of thought. The areas we are focused is highlighted in green on the slide. While we don't want to compete with our customers, we are looking to develop partnerships with key customers to develop IoT solutions. We want to offer what we call Sensor Plus products that complement our sensing elements with connectivity, data transmission, security, edge intelligence, and more. HVAC engineers are being challenged to design accurate systems that consume less energy. TE's advanced sensing technologies can be implemented in designs to help achieve these increased efficiencies. The sensing technologies used in HVAC applications include these areas of detection and measurement. We will spend some time discussing these technologies in a bit of detail, highlighting some of the advantages and innovations TE brings to the market. Pressure measurements are critical to many HVAC applications, from high pressure values to very small pressures measured in a few millibars or sub-inches of water. TE Connectivity has an extensive family of board-mounted sensors for measuring air pressures. The two technologies used for these sensors are a MEMS-based piezoresistive type and a thermal flow-based type. These sensors can be used as both pressure sensors in modes like differential or gauge, or can be configured in a bypass configuration to measure airflow. Our board-mounted sensors are used extensively in applications like room controllers, heat recovery systems, damper controls, and ventilation. Our SM family of sensors uses a diaphragm-based piezoresistive technique. These sensors use thin silicon diaphragms in which the resistors are embedded as a Wheatstone bridge. Simplistically put, changes in pressure result in mechanical stress on the bridge, which causes changes in resistance, which causes changes in voltage proportional to the pressure applied. This technology is well established, low risk, and is trusted and respected. It is especially suited for pressures around 1 millibar or 0.05 inches of water and higher. It provides highly linear signal pressure characteristics and excellent overall accuracy. These products are for dry, non-corrosive gas environments and are packaged in standard JEDEC 16-pin SOIC with plus or minus 1% accuracy. The SM5000, 6000, and 7000 have both analog and I2C outputs with total error band of plus or minus 1% full-scale digital and plus or minus 1.5% full-scale analog. The lower pressure SM9000 has an I2C output and total error band after board mount and system level auto zero of less than 1% full scale. Our L series of ultra-low pressure sensors use an advanced thermal flow principle of operation. This technology uses a heating element positioned between thermal resistive elements. Again, simplistically put, pressure differences are measured between the two resistive elements, and changes in temperature of gas flow creates an output that is proportional to the underlying pressure. These sensors can be used in differential mode or implemented in a bypass configuration to measure flow. Traditional thermal flow-based sensors create the flow channels as part of the package. Our advanced technology utilizes a single silicon chip with integrated microflow channels etched at the die level. This process results in very high pneumatic impedance with a performance level 100 times higher than our competitors. The extremely high impedance provides for immunity to dust and humidity and allows the use of long connecting tubes or filters without any degradation of performance. This family of sensors can resolve pressures down to 25 pascals or 0.1 inches of water and are sensitive to a pascal. Our LM series is calibrated for ultra-low pressure ranges from 25 pascals to 5,000 pascals with voltage as well as digital output options. Our feature-rich LHD module uses dual microflow channels to effectively maximize the dynamic range of the sensor. The highly sensitive sensing element is able to accurately resolve subpascal variations at low pressures, while the second element extends the measurement range up to 5,000 pascals. An on-board microcontroller with accurate 24-bit A to D conversion provides signal processing, including stitching of the response of the two sensing elements, linearization, and temperature compensation. TE has several sensing solutions for measuring fluid pressure. Our MSP, M, and 80 series families utilize a piezoresistive type technology in its pressure transmitter family of devices. These products offer options like media isolation, compact sizes, and both analog and digital outputs. They are ideal for chiller, heat pump, and compressor type applications. The M5600 series wireless pressure transducer is from the TE microfused line and is an example of some of the vertically integrated sensors we are developing for the IoT. This device is enclosed in a stainless steel and polycarbonate housing and is suitable for measurements of liquid or gas pressure, especially for difficult media such as contaminated water, steam, and mildly corrosive fluids. The wetted material of the pressure port is made of either 17-4 pH or 316L stainless steel, and the transducer's durability is excellent with no O-rings, welds, or organics exposed to the pressure media. TE has several development tools to help in the evaluation and characterization of our products. We have easy-to-use demo kits for our various pressure products that can be used with commercially available development platforms. In addition, we have several white papers which go into deep detail on the physics and principles of our technologies, as well as practical application notes which help with the evaluation and product implementation. And now I'd like to turn it back to Devin to look at some of the other TE technologies used in HVAC applications.
Thank you, Paul. Temperature is the most widely measured physical parameter. The critical source of data for not only personal comfort, but for digital as well as thermocouples. The most popular temperature sensors for HVACR systems are NTC and RTD based, as they provide the most cost-efficient designs and can provide the accuracy and temperature range needed for most HVACR applications. A range of sensor models are used in HVACR applications, and TE can supply temperature sensors that fill all of these areas, from sensor components and board mount sensors to fully ruggedized temperature probes and assemblies. There are a variety of specialized designs used in HVACR applications, and many sensors must operate reliably in the harsh environments typical in HVACR applications. That can include things like high moisture and freezing and thawing. TE Sensors is vertically integrated and manufactures from the sensing element to the finished probe, with specific designs for freeze-thaw, high moisture, motor embedment, and more. The table shows some of the general characteristics for each of the temperature technologies, along with advantages and disadvantages for each technology. While each technology has its place in all industries, including HVACR, NTCs and RTDs have been the most prevalent in HVACR applications. NTC thermistors are generally the lowest overall solution cost, and with a simple resistance output are simple to use. They are very accurate over the typical operating temperature range needed for HVAC and refrigeration applications, and with a very high sensitivity, the interface electronics is very simple and inexpensive. On the downside, NTCs are susceptible to moisture ingress, which is common in high moisture applications that also include temperature cycling above and below freezing, which is very common in HVACR cooling applications. Moisture ingress can cause erratic readings in the system and can lead to premature drifting. Special materials and processes can help seal the thermistor assembly from moisture, and TE has many years of experience designing a wide range of thermistor assembly designs specifically for applications in this market. Due to advances in manufacturing techniques and automation, the cost for thin film RTD elements has dropped significantly over the years and is now quite competitive with NTC thermistors. RTDs typically have very good accuracy over a broad range, much larger than NTC thermistors, and provides better long-term stability. They also can operate over a broader range of temperatures, especially on the higher temperature side, which makes them more suitable for compressor discharge and other HVACR applications that require continuous operation beyond 125 degrees C. On the downside, they have a much lower sensitivity than NTC thermistors, about an order of magnitude less, which typically requires more sophisticated and more costly interface electronics than NTC thermistors. Next, thermocouples are used in some high temperature applications and for some diagnostic systems. They come in several different standard types or curves and can be operated over a very wide temperature range. They are typically very rugged and can be manufactured in very small form factors. However, their output signal is quite small, on the order of a few millivolts. It requires cold junction compensation, more expensive interface circuitry, and is not as accurate as RTDs or thermistors. For digital sensors, they are becoming more widespread, where board mount or surface mount sensors can be used, such as for programmable thermostats and for some air handling systems. Accuracies have improved over the years and now rival RTDs and NTC thermistors. And because the output is digital, no additional interface circuitry is required, which means lower costs and no additional error is being added. Finally, thermopiles are used when remote or non-contact temperature sensing is needed, and also can be used for occupancy detection. Previously, analog thermopiles required a great deal of engineering know-how, as they required an additional reference sensor and compensation and calibration to obtain reasonable accuracies. The introduction of digital thermopiles with built-in reference temperature sensors and calibration data has greatly simplified their implementation and temperature sensing designs. HVAC systems have evolved from systems that just control temperature, heating or cooling or both, to systems that monitor and control not only temperature, but also humidity, air quality, and much more. From a humidity perspective, almost all of the newer systems monitor and display humidity levels, but many systems today, especially in an industrial setting, can control the relative humidity level in the building. Cooling systems by their nature extract humidity from the air, but by themselves are only effective when the system is calling for cooling. In order to provide the best indoor environment always, and to do so efficiently and effectively, many HVAC systems now include specific components for humidification and dehumidification. Humidity sensors play a key role not only in monitoring the humidity both indoors and outdoors, but also as key components in the monitoring and control of the equipment used to modify humidity. Also, for any type of refrigeration system designed for food or produce, monitoring and controlling the relative humidity is critical to freshness and shelf life. Humidity sensors have evolved from simple resistive devices with a limited range and accuracy to fully digital models that can measure both temperature and humidity over a wide range of conditions with high accuracy and little or no drift. Like temperature sensors, humidity sensors can be provided in several different form factors, including surface mount components, modules, as well as probes and assemblies. Most of the humidity sensors also include a built-in temperature sensor that allows for direct compensation for the raw relative humidity output. Some of the key applications for humidity sensors are listed in the table above and include building humidity monitoring and control, humidification and dehumidification systems, smart thermostats, supermarket refrigeration, as well as for refrigerated transport systems. Humidity sensors can be manufactured with several different technologies, each with its own characteristics as well as advantages and disadvantages. Most applications now require humidity sensing most or all of the entire relative humidity range from 0 to 100%. Relative humidity technology has been steadily improving the accuracy and stability of the sensing elements, and most of the sensors today provide fully temperature compensated readings in a standard digital output format. While position sensing is not as prevalent as pressure, temperature, or humidity sensing, there are still some key application areas in HVACR where position sensing and feedback are needed. Some of these applications include things like damper position, valve positioning and actuation, motor speed, and position. TE Sensors designs and manufactures position sensors using several different technologies, including board mount and isotropic magnetoresistive, or AMR, linear or rotary variable differential transformers, known as LVDTs or RVDTs, as well as encoders or cable position sensors, normally known as string pots. It even manufactures a line of position switches. Some specialized applications have been developed and utilizes a standard AMR sensor to monitor rotational angle for a dial of a programmable thermostat that is used to adjust the temperature setting and is a general user interface. Different technologies are used to implement position sensors, and each technology has areas where it performs well and other areas that it is not well suited. The table above lists 5 different position technologies along with 9 different parameters that could be important in an application. As you can see, no one technology outperforms all the other technologies, and the best position technology for the application will come down to determining the key needs for the application in terms of temperature range, accuracy, ruggedness, and other areas, and finding the sensor technology that meets all of the requirements at the overall lowest cost. Most technologies are non-contacting, which in general provides for better overall reliability and cycle life, but does require careful attention to material selection, as well as understanding the environment the sensor will see, including the amount of vibration, as well as the proximity of magnetic fields and EMI. Has been around for quite some time, that the sensor technology are applications. Electronics, technology, cost, and performance and ease of use have increased, which is driving the increased use of vibration sensors. Vibration sensors play a key role in a wide range of IoT or IIoT applications and are a key component of many condition monitoring applications that allow for the implementation of predictive maintenance for key components in HVACR applications, including things like compressors, fans, motors, and other rotating equipment. Vibration sensors come in a number of different form factors, including embedded or board mount sensors, wired or plug-and-play sensors, as well as new wireless versions for standalone machine condition monitoring. TE Sensors designs and manufactures sensors in all of the various form factors and utilizes different vibration sensing technologies. One unique vibration sensor recently developed by TE is the 8911 wireless vibration sensor that includes built-in edge computing that simplifies the interface and does most of the analysis of the raw vibration data. The 8911 combines a sensor, data collector, and radio in one rugged sensor that provides both vibration and temperature data. The sensor can monitor a wide range of vibration, up to 50 Gs, and has a very wide frequency response, which allows it to detect a number of different potential failure modes, such as bearing wear, imbalance, and several other conditions, well before the actual failure occurs, and allows for the replacement or repair of the equipment, and minimizes downtime and the cost, and eliminates the damage that can occur to other parts of the HVACR equipment or system. There are three common technologies that are used in vibration sensors and include MEMS-based piezoresistor technology, MEMS variable capacitive technology, as well as piezoelectric technology. The three technologies are compared above in terms of their typical characteristics, as well as their advantages and disadvantages. Piezoelectric technology shines in applications where frequency response is important, as well as temperature range. Frequency response can be critical to determining potential failure modes in rotating equipment, as well as bearings and motors often found in HVACR equipment. Especially for larger and more expensive HVAC equipment, like rooftop chillers and other commercial heating and cooling systems, vibration sensors provide a cost-effective way to detect potential failures, improve overall efficiency, and minimize downtime. Okay, now I'm going to turn it back over to Paul to discuss some real-world use cases for sensors in HVACR applications.
Thanks, Devin. With regards to application and design successes, TE has worked collaboratively with many companies to help provide energy-efficient solutions for their complex application requirements. We are actively working and supporting with many customers in their full production designs. We have unique sensor solutions for pressure measurements in ducts and for use in VAV and room controllers. Our pressure sensors have the ability to resolve very small pressures and measure very low airflows. These devices are immune to the effects of dust to humidity, conditions which are sometimes present in these application environments. Our pressure and temperature sensors are used extensively in heat recovery and thermal airflow measurement designs. We also have the ability to vertically integrate or scale up our technologies to include multiple sensing elements in a single module or subsystem. These can be used for custom or private label customer-specific products. Sensors are used extensively in a wide range of HVACR applications, and TE Sensors has the capability and technology to design and manufacture an array of sensors from simple epoxy-coated NTC thermistors used as air temperature sensors to sophisticated flow-based pressure sensors with very high sensitivity and high resistance to dirt and debris. These sensors are used in systems that vary from simple portable room air conditioners to very sophisticated chillers in building management systems. As a global designer and manufacturer of sensors with sites located in all regions of the world, TE Sensors can support medium to high volume projects with worldwide engineering, manufacturing, and customer support. TE has partnered with several HVAC OEMs to assist in the design and development of custom and semi-custom sensor products that have been designed from the ground up to meet the unique needs of each application. Our temperature sensors and pressure sensors are used extensively in large-scale designs and major HVAC OEMs in both commercial chillers and water and air source heat pumps. These applications require sensors to operate in very harsh environments with rapid temperature swings, condensation, and high vibration. Reliability is critical, as these systems are typically very expensive and designed for many years of life. Systems typically have upwards of 10 to 20 sensors that are used to monitor and control the system and ensure accurate temperature and humidity control and high efficiency. Additionally, many systems are installed on rooftops and other difficult to access locations that makes repairs and replacement of components particularly difficult and expensive. With extensive experience in HVAC and other harsh environments, TE has developed specialized designs, materials, and processes to ensure years of reliable operation in these types of applications. Similarly, our temperature, humidity, and pressure sensors are used in large-scale refrigerant transport systems. The environment in these systems is like that in chillers and heat pumps and has similar requirements for high reliability and durability. Shipboard refrigeration systems must provide a tightly controlled temperature and humidity environment for a range of food, produce, and other high-value products. It must operate reliably for days, weeks, or months at a time with no ability to make adjustments or replace any system components. Sensors are critical components for these systems, and their reliability is crucial to the overall reliability and efficiency of the system. This concludes our presentation for today. I'll now turn it back to our moderator for some questions and discussion.
That was a good, very impressive presentation from Pro and Devin. So we have collected some of the questions from the floor. Okay, so yeah, I think we'll give 1 or 2 minutes, okay, for the rest of the participants. If you have any more questions, don't hesitate to put down your question now. Yeah, while we are waiting for the participants, Vincent, I think you can prepare to put up your slides. Yeah.
Thanks, Kwan. Okay. Thank you, Paul and Devin, for the presentation. I think I have just like to share some additional presentation for the HVAC. Just some more details. Let me share my screen. Okay. Just now, as Devin and Paul mentioned, we actually have quite some sensors used on HVAC systems. So just now we just go through them a little bit fast, and for some details, I think I would like to show more here. Okay. For the pressure sensors used in HVAC, actually we have the airflow measurement purpose is to measure the airflow rate inside the HVAC system. So just now we have we have a question about this. So actually we have for TE we have actually the airflow sensor, and we also have the pressure sensor used to monitor the airflow measurement. So both sensor solution can achieve this purpose. And another way is to measure the air fields monitoring. This actually is very common application for HVAC to measure the both side the pressure difference on both sides to monitor how's the back pressure on both sides to make sure that filter is in good and healthy condition. And just now we mentioned also VAV. This is variable air volume control. So this is really a good system for the energy saving and the energy efficient. So we used to help with the tempo control. So anytime we need to add more air, we control this one, and the pressure sensor is to help with the signal feedback. And we have also the leak, and we also have the leak detection. This is easy to understand. This to monitor how's the pressure inside the HVAC system. Okay, and the energy recovery ventilation is easy to understand. Just to make sure we don't lose the energy. We have the new air inside and the exhaust air outside, but we have the energy change on the middle. So this is a system. Yeah, normally for this system we need the pressure to control the go and the in and out. So on the right side you can see some of our successful story. Some of the real products we mentioned here for actually for different kinds of application, but the concept is quite simple. The concept is quite similar. Okay, and just now airflow sensor. Okay, we have airflow measurements. Actually, we can measure the airflow in terms of the mass flow and also the volume flow. This depends on we will use our TE pressure sensor, and then there will be calculation based on the pressure change, and then figure out how is the measure the mass flow rate, and also the volume flow rates. Okay, and yeah, this is generally for classical manometer concept for the HVAC application, and based on the pressure sensor. We don't go to more details. And for this one, all phase plate actually is easy to understand. For the concept here, actually we have the differential sensor, and we can detect the pressure before the all plate and after all plate, and then we calculate the differential pressure change, then change to the flow rate. So this is just a theory for us to understand, and this is for the tempo control. This is the concept of the VAV. Just now we mentioned, and we actually Paul just now mentioned this one. This is very good for our HVAC controlling system to save energy. Okay, air field monitoring. Just now we see the theory, and we see the concept, and this is easy to understand. That we will have the differential sensor, pressure sensor, to monitor before the field pressure and after the field pressure, and we can monitor how is the condition of the field. Is it with too much dust or not yet? And we customer can monitor this and see when is the right time to change the field to avoid too much energy loss. Okay, And for the leakage detection is easy to understand. I think everyone can understand this. This is a pressure sensor. We use differential sensor. Okay, and the energy recovery ventilator. Just now we also share this concept, and this is the real products like this. So this one, this is also commonly used in smart building, currently in HVAC system to save energy, to exchange the energy from the in air and the out air. Okay, and this is the control box with our pressure sensor inside to detect the pressure differential pressure to provide the control system a good signal when to kick off the action. All right, so for the sensors, just now Paul and Devin has also mentioned to many of the parameter details. So I don't want to go too much details, but I would like to highlight that for our pressure sensor, we have quite full pressure sensor range. Start from big pressure to very low and ultra low pressure range. So, and next we also have a really small pressure sensor. We can detect really low up to 25 Pascal. So this is really low pressure, and we can keep really high accuracy, 0.5%. So based on this technology, we can detect really small differential change. Okay, we just skip those products, and I would like to share one more presentation of the successful story. Just a moment. Okay, this is another successful story like we see nowadays. Like most of the building, they start to consider add this kind of system to the new building, and to make sure that when there is any fire accident, we can make sure that there is no air going to the stair house, going to the stair, so that people cannot get hurt by the harmful smoke. So we call this application fire ventilation system. So based on this ventilation system, we have the sensor in both area of called in-house and the isolate and some of the sensor outside and on the stair area. So we make sure that the pressure inside the house, or the pressure just on the antechamber will know bigger, will be small than the stair area, so that when there is fire accident, then smoke will not go inside to the stair area, so that when people they run to the stair area to go down to the building, they will not hurt by the harmful smoke. So the concept is easy, but right now the application is more and more popular. So we have the sensor of SM 7000 to monitor this kind of different really small differential pressure change. So that there is a system monitoring the different pressure in different area, and make sure that there is a pressure gap between each other to make sure if there is any fire accident, the smoke will not go to the wrong place. Okay. So this is the one of our application for the real product you see on the right side. Is actually a module to detect and measure the pressure difference on different areas. And because our sensor can reach really small really good accuracy and really go down to really small range, so we can get more accurate data to make sure the control is correct. Okay, and this is some of the comparison to other products. Okay, so this is the fire ventilation system I'd like to share. For the popular application going forward, and now we see the tendency is it seems like more and more popular in the market. Okay, so I hand over to Kwan for the next section.
Thanks, Vincent. I think that is a great presentation. And also, I believe you all can see that TE sensors today can actually offer a lot of industrial grade sensors, for many kind of applications. And I think just now, throughout the webinar, we also collected some of the questions from the participants. Actually, I would like to get my FAE's help to read out those questions.
Okay, thank Kwan. So in fact, we are collecting some of the question for the audience. So we have one question from the floor. So Winston would like to check with you about what is the main consideration when there is a sensor request on the HVAC pressure sensor?
Okay, as I just mentioned, actually we have a really good full range of pressure sensors. So considering to using the TE pressure sensor, actually we need to consider some of the main functionality. Actually, firstly, we need to make sure that the sensor is simple and reliable on the application. Because this is actually some of the critical requests on our HVAC applications. And also, of course, we need to also consider the most of the application, I mean the sensor parameters that suitable for the specific application. And for some of the spatial, for some of the spatial requests, like for example, just now we also have another questions for some of the HVAC tubing. Actually, there are dust and this is actually a really harsh situation. So we need to consider some of the dust-proof solution for the specific applications. Yeah.
Okay, thanks, Vincent. So actually, we have another question. The question is, what are the normal parameters that customer need to take into account when there is a sensor for HVAC applications?
Okay. For sensor application, actually, HVAC we really need quite a lot of sensors. So firstly, we need to make sure the type, of course, if it's a pressure sensor or a temperature sensor, and also we need to make sure that how is the range of the sensor based on the specific applications. And also the important factor is also how is the accuracy needed on the application, and we also normally need to consider how's the assembly based on the customer design construction and so on. So we normally for each opportunity, we would like customer can provide the more detailed, the better our understanding on the application to help with the proposal of our TE sensors. Thanks.
Okay, thanks, Vincent. So actually, I received another questions from the floor. Any success story for commercial refrigerations and air conditioning by using a pressure sensor?
Yes, we do. Actually, we have really good pressure sensor M5200 series of pressure sensors specified design for this kind of commercial refrigeration and conditioning applications. So the pressure transducer is really good with analog signal based on the full range, and the accuracy is also really good for the application. So it is targeted for the refrigerator and the air conditioner application. So, but that's yeah, for different kinds of commercial refrigeration, we also need to consider different I mean specific applications. So yeah, we can talk if there's a real specification request.
Okay, thanks, Vincent. So I believe
Yeah,
that
thank you.
actually, yeah, I believe that TE actually has a great products profile for the HVAC applications, including for the pressure, temperatures, positions, as well as for the humidities. They are generally used for the HVAC. As I mean, just now the presenter, the speaker has been covered. So is there any more questions, I mean, from the floor so that we can answer your questions? Okay, I think we had, I saw one more questions. Do we want to address, sorry, okay, about the leak detections.
Yeah, I see this question on our Q&A leak about the from hazmat. Leak detection refer to supply air, dust, or chill side leak detection. I think this is more about the supply air and the leakage. Because our application is to monitor the how to say this is to monitor the pressure change inside the tube, the ventilation tube. So the purpose is to detect how is the pressure change, is that normal compared to the benchmark. If not, we find out that there's a leakage. So I think this application is more likely to, as you just mentioned, chiller side leakage detection. Yeah, hopefully this answers your question.
Okay, thanks, Vincent. So, Kwan, do you have anything you want to add on?
Yes, I think I saw one more questions from the floor. So the similar type of solution are already available in the market. Then what are the advantages of TE sensor at top of the market solution? Usually we face this question a lot lah. So what we typically do is that we need to also know what solution today you are comparing with. Then we need to study both the specs of our competitor part as well as the TE sensors. Yeah, then we will be able to address to you, this will have to be compared in something more detailed. Yeah. So
Yes.
then,
Yeah, agree, Kwan. I think I add my comments to this question. Actually, for TE sensor, actually for each applications, we have the different advantage. So, for example, for especially for HVAC application, for HVAC application, normally for our I mean ventilating the tube or ventilating condition, we actually need to have much dust. So in this kind of situation, many of the pressure sensors after when the sensor using after 1 year or maybe 2 years, the sensor will start to get stuck by the dusting. So for our series pressure sensor, actually we have the very specific and the very unique design of the we call micro thermal and the micro channel technology to make sure that our sensor can be dust proof even for more than maybe more than 5 years or 10 years application without any problem. So some of our customers will compare our sensors to other competitors' sensors based on this kind of situation to make sure the long-term stability. So we have actually different sensors with different and unique features that we can share to you on the on each application. Yeah, thanks, Kwan.
Good. Yeah, I don't see more questions from the floor. Anyway, if you all have after this session is over, if you all have any more questions, you are welcome to drop us an email or contact our officers that's nearest to your location. So I also did actually put my email address at the chat there, so that you can take note of it. So again, yeah, I want to thanks everyone for spending your time here today. I hope that this webinar able to bring you a very good information. Thanks a lot for everyone's time. Goodbye.
Thank you.
Thank you. Thanks for joining.
Thank you very much.
Thank you. Thank you for Excelpoint for holding this webinar. Okay, bye.